All right, well, welcome everyone to Introduction to Real-Time Indoor Air Quality Metrics and Scores. This course is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the places we live. Today, I will be your moderator. My name is Brett Little. I'm the program manager here at the Green Home Institute. As with most of our sessions, we are approved for multiple continuing education, some that we'll report, some you have to report, including our own internal certified green home professional designation under the health pillar for this session, as well as AIA health, welfare, and safety, which may make it applicable to your state-based design or contractor license. At the time of this webinar, December 1st, we know that you are in the end of the year mad scramble to get your continuing education. I get it. I don't report my CEUs until literally the day I'm about to be expired. So please become a member and you're going to get instant access to over 60 CEU courses that you can access at no cost on our Thinkific platform channel. And you're going to be able to get that cleared out so you don't have to worry throughout the holiday season here. You can get access to those and all of these webinars you get invited to for free. Plus, we're going to send you this Corn-Base mug grown right in the USA, made here. We have a few left here, so check that out and get signed up. And before we get started, I want to say a huge thanks to our top tier sponsor, Panasonic Ventilation. They have all sorts of ventilation applications that can make your needs to help ensure that your home and your clients' homes and projects are healthier. I wanted to share this with you. If you go to their website, it's just stunning what they have here. Bath fans that can be used in bathrooms, in kitchens, in ventilating spaces, all sorts of different choices here, all the way down from 50 CFM, I believe, up to 150 CFM. They even have the Whisper Fresh Select Air Supply Fan, which is going to bring in that fresh indoor air if you're using a supply strategy. So many different fans you can pick from depending on what your goals are. Taking it to the next level to get that balanced ventilation, you're talking about the IntelliBalance. I have an IntelliBalance 100. Cold weather climate, works when it gets super cold. They just upgraded to 200 if you need it for larger homes, larger office spaces, and they have a decentralized one that we see a lot in some of our affordable housing LEED projects. Beyond that, they have other ventilation system products here, a range hood pressure sensor. So if you've got one of their range hoods that goes over 400 CFM, it'll sense that and it will bring in more fresh air. They've got the Select Cycler. So if you want to do a balanced system with the bath fan and the supply without paying for the ERV, go for it. You can do that. And then also they've got super quiet range hoods that are going to work, and they connect with their Cosmos system. So when air pollution is detected in the house, like PM 2.5, it'll turn it on and exhaust it. I see it with my own eyes using it here myself. So go and check them out over at Panasonic Ventilation today. And then also thanks to our second tier sponsor, Ava Window, PVC windows up to R7 near passive house design. And also they've got aluminum windows, which has some recycled content in it, which is pretty cool if you're trying to use something different other than PVC. So check them out over at avawindow.com. Now, before we get started, I wanted to mention that this course is approved for CEUs under LEED for O&M, operation and maintenance, NC, and homes, focused on indoor air quality and monitoring of the indoor air quality. So what we're going to talk about today has a lot to do with real-time monitoring. I'm really excited. It's very important. It's the direction all the green building programs are headed. It's the direction that we need to go. We monitor fire. We monitor carbon monoxide, right? It's just the next level. It's where we're headed. And so the green building programs, they have obviously pull ahead of the code. And so we're going to be talking about some of these and referencing them at the end and how they fit in. Some of these credits, of course, are more laboratory-based testing, but the real-time monitors are actually going to be providing some of the things you need to do for that. So with that, I am super excited to have Dean Young from Aware as our speaker today. And so with that, I'm going to hand it over to Dean to introduce himself. And Dean, please do take it away. Thanks for joining us.
Hey, Brett, and everyone here. Super excited to be here and share more information about indoor air quality on head products at Aware. And yeah, want to dive into it. So, um, yeah, as Brett mentioned, we're going to be looking at real-time indoor air quality and kind of basic scoring to kind of help you understand, decipher those numbers and what that all means. But a little overview of the agenda first. So, do kind of an overview and why, I think a lot of folks here might already be, super uh, aware or air aware even. But, there's still some edge cases here and there that we can look at. How you might want to remedy, and that may be different based on which systems and everything you have available at your disposal. And then, as Brent mentioned, I'll go briefly into the LEED certification, like how we can apply IAQ to that. And then we'll go more in depth afterwards. But yeah, feel free to use that chat for questions and, potentially stop along the way if anything is relevant to that section. Yeah, starting with that overview. So I think when Martin Luther King, made this statement, about clean air being a human right, things were a lot different in the U.S. in particular. Certainly, places around the world have varying degrees of outdoor air quality. There might be more factories in some regions, or pollen, or other pollutants from roadways, and etc. But the lessons from that era, the 60s and 70s, which of course for me was before I was born, but grew up learning about the horror stories of acid rain and other things that have left scars on the country. But in that outdoor air quality, those lessons from that period are still applicable to nowadays. And the reason, so we've got all that pollution outdoors that could even come indoors and infiltrating in the home if it's not well sealed, or if you don't have advanced systems or filtration and ventilation. So it's something to keep an eye on from coming outdoors. But we also have a lot more sources indoors nowadays. There's certainly CFCs and ozone and cleaning products, and the lack of like proper filtration tools, on the order of HEPA and other fine particulates, which we've come to learn over the decades is particularly bad for human health and can exacerbate or even cause certain health conditions. So super important to pay attention on these. We'll kind of dig into each of those. So we have both a residential and more of a commercial solution. What you can see there is our Aware element. That's more of our residential unit, kind of tabletop desk placement, and plug it into the wall, connected to Wi-Fi. Super easy to get started in your journey of continuous monitoring and data collection. And I want to highlight these 5 particular air factors: the temperature, relative humidity, carbon dioxide, total volatile organic compounds or TVOCs, and particulate matter 2.5 microns or less. Not all of them might, initially strike you as a sort of air quality or environmental quality metric, but when you think about the outdoors, you got things like AQI and things like that. But for the indoors, where we have more control over our environment and where we spend most of our time, in that 90% of our day, usually if you spend more time outdoors, kudos to you. But certainly, especially over the past couple of years, been cooped up quite a bit indoors. And So really all these factors influence our health, well-being, performance, job performance, cognition, things like that we'll get into. So looking at these different air factors and what are some preferred ranges or recommended ranges there. So we've got an kind of a more or less proprietary IAQ score that essentially made up of these ranges, and it's geared towards kind of nudging you back to those optimal readings, again, for health, comfort, safety. So, on the temperature side of things, apologies for not including Fahrenheit there, but for the rest of the world, the Celsius, you're looking at the kind of mid 60s up to like mid high 70s for that optimal. If it's too hot, well, we'll get into what happens when you get into more of those like yellow, oranges, and red zones, outside of that green optimal zone. Relative humidity, it's roughly that like 40 to 50%. I think, depending on the certifications and other bodies of research, there might be a little bit wider gap there, from kind of like the 30s to about 60 or less. Carbon dioxide, now for like a really high performing space, you want to try to stick to 600, 800, 1,000 ppm. You really start to push into again, some of those cognition and sleep quality, all those sort of things might come back to bite you a little bit. VOCs, again, performance wise, you want to be heading to roughly less than 300 ppb. So we measure in ppb. You might also in some places see micrograms per meter cube, and there's some ways to do some conversions there. But really trying to stay well below that 1,000 mark. Above that, you probably got some sort of indoor source that's constantly off gassing or something like that. Particulate matter, so that fine dust, and really honing in on that 2.5 microns and less. For outdoor, this feeds into AQI, WHO recommendations, things like that, have geared towards even much lower, I think nowadays than 15 micrograms per meter cubed. But as I like to say, no PM 2.5 is a good amount of PM 2.5. So you want to try to keep that as low as possible. We're focusing here just on kind of like continuous and real-time monitoring. A lot of standards and things and outdoor, for example, will look at time-weighted averages, so over the past 24 hours, the past 8 hours, things like that. So there's some different monitoring and calculation methods that you can use to calculate your exposure. Moving along. So now that I've talked about and hinted at some of the reasons why you might want to measure, let's dive into that a little bit more. Obviously, health and safety is even bigger. There's more awareness lately than I'd say, certainly the past couple of decades. But especially in the last 2 years, we spend 90% of that time indoors. I think I saw that flu rates are like astronomically lower than they've ever been before. It's partly because we're not like commingling in indoor spaces as much. But I think, with things like wearing masks and just more ventilation in spaces, we're diluting the air. And in those indoor spaces, again, where we have more control to affect those health outcomes. So they're really strong indicators. That's why we've contributed to these better health outcomes by controlling that fresh air intake and removing pollutants and contaminants from the air. And really, by monitoring these continuously and having historical data, we can kind of unlock some of these secrets and really point to more of causation than purely correlation. Another reason I kind of ended out with particularly carbon dioxide is increasing productivity and comfort. Temperature and humidity also play effects on this, but as Harvard and Joe Allen have done a lot of research into the effects of carbon dioxide on cognition and job performance, and spills over into sleep and everything else. If you crack that window, and I've seen this anecdotally so many times, even employees at Aware will remark, as soon as they get their device on first day they start, by cracking that window and seeing their CO2 levels come down from what they used to be overnight, they really influence, gotten better night's sleep. So the real immediate impacts of reducing the CO2, not only increase that productivity and make you feel fresher, and CO2 is one of those things that it'll kind of creep up on you. So you might not realize that you're feeling kind of woozy and things. That, how many times you come out of a conference room or a well-sealed room with the door closed and no ventilation, and walked away saying, getting really, maybe call it afternoon slump or something like that. But it's it kind of sneaks up on you, and so by monitoring it in real time, seeing those values and dialing those in through certain actions, then you can really improve your livelihood. So there are other things, and VOCs, off-gassing will give you flu-like symptoms, make you kind of drowsy. So that, again, this could come from laundry detergents, other cleaning products, air fresheners, candles, anything else that has a scent is often, those can oftentimes be VOCs. Maybe not like in the super critical, harmful range, but certainly people have different reactions to these different chemicals, and they can influence the ability to focus and then also, again, if you're not getting fresh air every once in a while and the air is very stagnant, which can be seen through CO2 levels and kind of dissipation rates, then that stale air just kind of lingers, and oftentimes you can smell it, and it's very distracting, uncomfortable, and probably again reducing your ability to live a healthy life. And then I think also on productivity and comfort side of things, I think we often think of really hot, really cold, too much humidity, with or even too little can dry out your airways. But too hot and humid is just very uncomfortable, and so again affecting that kind of focus and optimal performance. So got all these problems. Oh yeah, Brett.
Yeah, Dean, there's a question that came in, talking about the office, right? And this, or even multifamily buildings, right? Spaces that we're sharing together right now, which is of concern. And the ability to be able to measure CO2 in real time, I think, can be very important. Can you just tell us what you know, or can speak to how, being able to measure CO2, what kind of inferences could there be connected to airborne viruses, influenza, coronavirus, you name it?
Sure, yeah. So anytime you have stale air, you have things lingering. There's no air movement. There might be a little bit of transfer, but viruses are even smaller than that like fine dust of PM 2.5. They can kind of glom together with some humidity and things, and become a little more detectable in that range. But the more that those viruses and bacteria and mold and dust mite and other allergens linger in the air, the more exposure you get to them over time. So there's a at the very least a correlation, if not a direct causal relationship between the staler the air is, the less that you are kind of changing that air out, through ventilation, which could be bringing in fresh air to dilute, or kind of recycling and filtering, things like that. Then you're trapping those allergens, diseases, etc., or you're flushing them out and you have less contact with them. So the more air changes you have per hour, then the less likely it is for you to be exposed to those. That doesn't make it impossible, but it definitely it really helps. And so CO2, TVOCs, PM 2.5, these can all be great indicators of how stale the air is or what's in the air, and you need to do more of that filtration, dilution, overall ventilation to get those levels down. Great. Yeah, that's a really good question. I think there's there's kind of a logic to it, but it's not immediately obvious. But I've seen over time that message is getting out there, and people are understanding the importance of ventilation in particular. So yeah, how do we remedy these issues? And again, this may differ based on what you have at your disposal. I, for example, in a rental home, and so I'd have to convince my landlord to make major infrastructure changes. On the complete opposite end of the spectrum might be a commercial office building, and a lot of them are looking at retrofits and changing systems, and they've got building automation and controls for the HVAC and everything else, but they might not have access to open windows, that I often utilize in my home. But and then in the middle there, and I'm sure for a lot of folks here, you might have HRVs, ERVs, and those can be extremely helpful. But to get into some general recommendations, first and foremost, a clean house may be a healthy home. So again, by filtering out or vacuuming, things like that, making sure that any dust which contains, again, those mold spores and the pet dander and viruses that have stuck onto other things, or come together with increased humidity and things like that, that's all falling out of the air in sort of like a relatively stable, no airflow environment, and forms eventually into dust. So find all sorts of things in that dust, and you want to make sure you're cleaning that up. Though make sure that if you're using vacuums, that they've got something like on the order of a HEPA filter. Otherwise, it's going in there, you're trapping the big stuff, and then the PM 2.5 just goes straight out the back of that fan. And sometimes based on the design of the vacuum, it might be straight in your face. So want to be cognizant of that. Yeah, and again, like the more clutter you have around, the more chances there's for these contaminants and dust and things to accumulate around them. So cleaning those up. Yeah, if you've got those filters, make sure they're clean. Replace them, according to your HVAC or filter supplier recommendations. I think we like to think that as consumers that they're just trying to get more money from us and stuff, but there is a big impact of a dirty filter, in the performance of your equipment. But then, the more that gets clogged up and reduces the efficiency, then the more that dust and contaminants linger in the air. So the cleaner that is, and the more air you got moving, that's really good. Keep going. So you want to look at, again, for folks like myself that don't have access to those whole home systems, maybe just heater and running through the HVAC filter. Natural ventilation is really great. Opening windows, or, as I mentioned, sleeping overnight, cracking the window a little bit, leaving the door open, letting CO2 diffuse throughout the entire space as opposed to concentrated in a closed off smaller room. You might be surprised how high CO2 gets in a bedroom in the middle of the night, especially a well-sealed home. I think there are all sorts of new techniques and strategies on this. I was thinking at the beginning when Brett was talking about those like silent, I think Panasonic air handlers and things. I've got a bathroom exhaust that's like extremely loud, so we don't leave it on all the time, but it would probably be great if we did. Same with the range hood. I don't know, maybe there's also a psychological thing there, like it must be working if it's really loud, so moving a lot of air. But so there are things that you can do kind of intermittently throughout the day, and but you can only know when it's relevant to like open up those windows without having other adverse effects, such as maybe you live in a humid environment, opening the window, letting all that humidity in, and that can cause other problems. So really, again, coming back to those 5 main air factors: temperature, humidity, carbon dioxide, TVOCs, and PM2.5, you want to measure some of them to treat certain aspects, but then you want to make sure by treating you're not causing more problems. And using a dehumidifier, more humid climates. I think we might even be coming up on the drier season indoor, although my air here personally says that I'm usually in the 60 to 70% humidity in San Francisco, even in the winter. Still trying to find strategies to deal with that one, but there are a lot of sort of mechanical and then natural ways of controlling humidity depending on outdoor, indoor circumstances in your region, just running those bathroom fans and kitchen fans, even from boiling water and whatever else that may involve running water, can be good to flush that out. So a lot of strategies there. You could go on and on all day. So I wanted to touch briefly on the LEED. As I mentioned earlier, we'll come back around to that with Brett in a little more depth. I think if I understand correctly, there might be a lot of people here interested in LEED for homes, and maybe even multi-residential and other office buildings, for example, and they all have the need to monitor for air quality. There's a lot you can do with that information. I hope that I've kind of called out the importance and how and why. but the strategies might be slightly different, but air quality affects all of us. But kudos to everybody, is going above and beyond and LEED for homes. My hat's really off to you. So there's one section around indoor environmental quality performance and surveys of occupants and data reports. Make sure to find an air quality monitor with easy access to data, which will make that reporting really easy. So things like calculating the 95th percentile of CO2 data and calculating averages and looking at the maximum readings for TVOCs can be helpful there. So for enhanced indoor air quality strategies, so I guess there are a couple of points there, but for a lot of these, there's some, just wanted to highlight, like there's some things that continuous monitoring, real-time monitoring might not directly help, might not get you those points, but they can definitely give you some context to work around to just supply some more information so that you're better equipped to get these points. And so for strategy 2, 3, 5, and 6, what does it mean to have increased filtration, ventilation, preventing that cross contamination between rooms through continuous monitoring, through these 5 different air factors. You can see some of these effects at play in real time and adjust accordingly, or are you doing enough, so that when you have those more in-depth analyses and studies, or experts who come out and stuff, like, you're not wasting their time, you're not wasting your time, you're all prepared. And then more directly, there's carbon dioxide monitoring, which we talked a lot about, and additional source control monitoring, which those pollutants indoors that are contributing to poor air quality. And then even on contaminant control, again, a couple of points possible there, and might not be directly relevant, but when you do a flush of the building, and it's fascinating to look at the data and see, like, okay, like this is really effective. And I know, like, a lot of commercial clients will go in yearly or even quarterly and do a flush, like a reset essentially of the building, even though option 3 here might be like pre-occupancy, geared towards that. Again, as you're more aware of the issues and things, there might be some of these strategies you might want to perform on an ongoing basis, to just help with overall health and wellness. Yeah, and then air testing again, like, are you prepared, and for that option 4, do you know what's kind of your baseline, and so when you come and sample and do the professional testing, you're prepared for that. Cool. So yeah, covered a lot of information, and I could go on forever. Look forward to any questions, and I know Brett's going to cover the LEED in a little more depth. So yeah, thank you.
Hey, great. Thanks, Dean. Yeah, I see quite a bit of questions here. And before we get to those questions, I just want to go over a couple more things. Can you see the intro slide again on my screen?
Yes.
All right, perfect. Thanks for letting me know. Yeah, just real quick before we get to those questions again, and we still got some ways to go, but just as a reminder to everybody, for those of you watching this in the future on demand, not right now, take your quiz. You can find it on our Thinkific channel, GBCI channel, whatever channel we may be on in the future, you never know, and get an 80% passing rate to get your certificate. For those of you listening live right now, here present with us, you will receive an email if you stay the entire time. Certs at gutenbergcerts.com. Check your spam if you don't see it. mark that as safe right now. So you get it, should be coming within a couple days. So again, just a reminder on the LEED front, the sustainability front, we're looking at LEED BDNC homes V4, and it's an innovation credit for V4.1 single family contaminant control section air testing, which has actually been removed so far from single family V4.1. And then for LEED NC V4.1, apparently air quality measuring is required, which is great. I didn't even know that until I looked it up for this session. I don't do a lot of LEED commercial. But minimum indoor air quality performance requirement. And then on the right there, enhanced indoor air quality strategies for your bonus points. And then below that, LEED O+M, operations and maintenance. Again, what I really like about the LEED O+M program for multifamily or for commercial buildings is that it's all about real tangible metrics. You have to show energy, water performance, and you have to show air quality performance and be able to prove it. And this type of application, these systems that we're talking about today are going to help you get there. So let's take first a look at LEED NC, the requirement. Monitor, so there's a lot to this requirement. We're not going to get into it about basic air quality management. And there's some differences for if you have residential units too, which we don't see often unless it's a huge high-rise building. But there's a lot here. You can check it out on the LEED credit library. But specifically what I want to point out here is the placing a monitoring system such as this into the thermal zone, or what I think a lot of them call sort of that breathing zone between 3 to 6 feet, and then being able to have it communicate just like this does. It communicates out a score. It tells you, it sends an update to the phone or to some sort of building management system that there's a problem, that CO2 levels are being exceeded. So that's very important. There's a lot to this requirement, but that's one part that's where you can use a device like this to achieve that. Now, if you want to get bonus points with this device, there are some different strategies you can use, and there's a lot to pick from here. But if you're taking the air quality monitoring strategy, then again, what you're looking at here is the ability to monitor that CO2 within this. And then also below that, you can see strategy 10. You might think through what other kind of things are going on in this building that we should be monitoring. So if you have a restaurant or an area with a lot of cooking, you might be saying, well, cooking is going to give off PM 2.5. Even if you're using electric, I can tell you from personal experience that you are going to burn something no matter how hard you try not to, and it's going to elevate to high levels of concerning PM 2.5. Even if you're electric, we encourage all electric. It's going to reduce the amount of PM 2.5, but either way, that's one thing, or you might say even VOCs, all spaces are going to be impacted by VOCs. So those are things you can be looking at. It looks like you get to pick here under strategy 10. And then moving on, LEED operations and maintenance. So this is the existing. So if you could take basically any existing multifamily building or commercial building, we can certify it under LEED. We can score it out to see how sustainable it is. It's important. And air quality has to be monitored. So there's a couple things going on here in this one. First, what they're looking for is your ability to monitor and survey about CO, carbon monoxide. So again, if you're all electric, hardly a risk. CO2, big risk when you put humans in buildings. That's what buildings exist for. Ozone, I don't know how you monitor that. Sounds important. And then PM 2.5, we just talked about that. And then also, they want you to monitor all these VOCs, which is kind of difficult to do with some of these real-time monitors. We'll talk about a little bit about that, but also TVOC, so you can get that. But the thing about it is you have to monitor these and survey them, or even take a one-time snapshot with like an industrial hygienicist. But your score is based on your CO2 and your TVOC and your occupant satisfaction survey. So what's important about that is these real-time monitoring devices that we're talking about here are going to give you that CO2. They're going to give you that TVOC for your occupants, for your clients, for the homeowners in the units, constantly going to give you that data. So there's no surprises when you go to submit for LEED certification. you'll have it. It's not like a snapshot. You'll have, a bunch of data you can show, hey, we are staying within our CO2 and TVOC thresholds, or if we're not, what's wrong? What do we need to do here? Because we don't want to be having LEED certified buildings that, have poor air quality. That would not be good. And then finally, moving into LEED BDNC, environmental quality contaminant control for V4, which again has been removed for V4.1, but it is an innovation credit, air testing. So this air testing here is taking a look at a couple different things. There's a lot of stuff you have to test. A lot of those VOCs, again, the same ones, a lot of the LEED programs, they're all consistent, right? They're very consistent. You got to test, and you at least have to see what's going on with all of these. But in this one for residential, you actually have to hit certain thresholds. But again, this is a great opportunity because this is for builders, right? And architects who, you walk away from the project and you say to your clients, hey, this is a healthy home. You say that because you believe what you did was healthy, but how do you really know? So we have builders, we have architects that are putting in these monitors right after construction is done, right before they turn it over to their client. They're either gifts or it's just part of their build process, right? And in these monitors, they're detecting these things like PM 2.5, TVOCs, and radon sometimes, you name it. And so that then you can say with this device, hey, look, everything I did, during the build process left you in good shape. So at this point, it's up to you as the owner to make sure anything you're introducing to the building or the way you're operating your home isn't going to reduce the air quality any further. And if it does, you can use an air quality monitor like this to at least identify some of the issues. It won't identify all of the VOCs at this point, but it will identify some of them. So these are some great ways to pick up and contribute to some of your LEED points. I also wanted to mention, I'm super excited to say that our own Green Star Homes certification program, when we launch the next version of it, to at least get to the gold or platinum level, we are making a statement that all homes must monitor air quality on an ongoing basis. Now, we're going to come up with the metrics. They'll probably be pretty close to the ones we talked about here today, but we think that's important. It has to have an air quality monitoring system in place that's working and probably certified to the reset standard, which limits it to a very few select. So I'm making that announcement here publicly. And then hopefully when we launch the updated version, you will see that in place. Many of our builders and architects who are working with us are already putting these things in place. So that's easy enough. So that's enough on LEED. We can get to some more questions, but before we got quite a bit of time here for questions. And before we get to those questions, again, as always, a huge thanks to our board of directors, our volunteers, our executive director, Jose Renya, and our top tier sponsors who are really contributing not to just more energy efficient homes for your projects, but also healthier homes. Mitsubishi going all electric, removing combustion, very healthy. Rheem heat pump water heaters, removing combustion. Again, April Air, humidity control, very important. How is that working out? And of course, Build Equinox, smart ventilation that detects air pollution in the air and then ventilates as needed, which is really important. So there have been quite a bit of questions here, quite a bit of comments here. I guess I wanted to, Dean, I think there were people just really asking about what other things can be monitored in real time or will be monitored in real time, maybe in the future as technology evolves and we can monitor more things that are actually, fairly accurate. There were questions here about mold, about mildew, obviously questions about viruses, which we talked about. And then I even looked at like that chart, that I showed for LEED that we need to measure, at least at a snapshot. VOCs encompass all of these different items. And I know there's even more than this, like there's a lot. Formaldehyde's a big one, right? A lot of people ask me, how do I know what's going on with formaldehyde in my house? So how close are we, Dean, to being able to look at these other VOCs, molds, mildews in the air and be able to make, informed decisions?
Yeah. This space is rapidly evolving. I mean, even the past 4 or so years that I've been with Aware, the number of new sensors from suppliers all over the world, the technologies that they're using to build those sensors, algorithms and sensitivities and everything else are just, I mean, I said to somebody else recently, like, we're in the golden age of like indoor air quality monitoring, or like right at the cusp of it, because the advances that we're going to see over the next year, 2 year, 5 years are it's going to start rapidly accelerating. So, I would not be surprised to see a lot of those particular VOCs become part of the commonplace, like continuous monitoring. It doesn't mean that all of those, and like we've got like a laundry list of the ones on our website and manuals and stuff like that for our devices that they are sensitive to. It doesn't mean you'll see them in every space. So, but it doesn't make them any less important to understand if they're there or not, because if you don't come in and do either that lab grade down to continuous monitoring study and collection of data, like, how are you going to know? You could be the like 0.001% of homes or something that's got something in it, or a building material that was put in there. And as we as you see the technology evolve, we can see things there that you didn't even know existed before. Again, PM 2.5, for example. I think when Aware started, we had just kind of like an aggregate dust sensor, and now there are like more suppliers out there, and getting down to even finer particles and larger particles and like the whole spectrum of particles, because the different ranges can or sizes of particles can correlate with certain things. Again, coming back to like mold fit into a specific range, and viruses fit into a specific range, and and then besides just measuring sizes and concentrations of these particles and things, I think I've seen some like cutting edge research and development around like testing kind of like a breathalyzer for COVID and things like that. So you can monitor in real time for very specific viruses. I mean, this stuff's like probably much further out, or would be extremely cost prohibitive to put into every space. But it just goes to show that, like, I mean, this is crazy where we're headed.
Yeah. Well, thanks for taking that one on. And kind of giving us that history. And, you brought up PM 2.5. And I remember over the summer, we had our Aware device set up in the bedroom and kept the windows open at night because it was getting nice out. And, you saw the pink sky in the morning. You knew that the wildfire smoke was here and it was diluting the sky, but you had no one had any clue that even up here in Michigan, that there were levels of PM 2.5 pouring in overnight, exposing us to, I think on your chart there, maybe sort of the yellow level, right? All night long. Maybe even at some points you saw it higher. And any normal person would be like, what a beautiful sky. This is awesome, right? What a gift, but and they kept their windows open all night thinking this is great. And, I looked at the monitor and it's just like, this is concerning to me. I'm breathing this. My kids are breathing this. I would have had no clue. And it was sad, shut the windows, turn on the ERV. And as you were mentioning, important to change your filters. We updated our filters to MERV 13. Boom, we saw on the device like plummet within 10 minutes. PM 2.5 wiped out and kept, unfortunately had to keep the window shut during those high times. But I think it's real information, and it can, obviously having moderate exposure over a couple summer nights isn't going to do anything, but it's that over time piece, right? So I was really excited to at least you know, be able to show something really tangible that due to an unfortunate situation with our wildfires. What there's some questions here about using HEPA filters, and what kind of studies do you have? Any studies or good case studies that you all can share of like the things that are working to really drive these numbers down? Like the one I said, like I knew I turned that MERV 13 on, I'm still taking in the outdoor air, right? I'm still taking it in, and it's still polluted with PM 2.5 from wildfire smoke, but the filter worked, it knocked it down. Like, what do you have anything like that that's that you can share or speak to right now, just anecdotally?
Yeah, well, in particular, I follow a lot of indoor air scientists on Twitter, and that community is just amazingly active. And getting access to like new research and everything that's like top of mind to them. And there's been a lot of pushes to have more air filtered, like even standalone units in classrooms. I think there are a lot of like chemical and mechanical and kind of light treatment, air treatment technologies, and seeing the scientific community kind of debate the pros and cons, and point out that like in some or a lot of cases, you might inadvertently like creating more problems. The intention was good, but you want to avoid something could just be broken or whatever. Even if the system's rated for a certain thing, you want to make sure that it's not creating more problems. But going back to the classrooms, I think what I've seen a lot is just getting air changes per hour, and so even if you've got a lower rating filter or a smaller standalone unit, or whole home or individual room or whatever ventilation systems, it all helps, right? They're additive effects of doing more. Do you need to like blanket the entire space with air filter? Like probably not. But again, maybe that's where continuous monitoring, indoor air helps, is seeing like the right balance of like cost and effectiveness. But yeah, so every little bit matters. Like if all you can do is MERV 8 or something, like do it. Better than nothing. Maybe it means running HVAC more often. I think there are also like a lot of studies coming out of like, well, and this kind of comes back to kind of sustainability and energy usage and things like that. It's like, well, there's a cost too, and getting more outdoor air and bringing that indoors. There are benefits, but there's also cost. And so how do you balance those and make sure that whether it's fire susceptibility or whatever else indoors, you're finding a good compromise there.
Yeah, speaking of virus susceptibility, you think about humidity, right? Obviously you don't want to be too high on the humidity scale because you're talking about mold, mildew, other, I can't say it, pronounce it right, rhinoviruses, but on the other end of the spectrum, of course, and here we're, my device is starting to show, I'm starting to ebb down into that 37-38%, right? And it's just like, gotta boost the humidifier now, which is helpful. And we know from, influenza, COVID could be worse off when the humidity is low. It could be easier to catch, harder to deal with. So having that information, I think, is super helpful in certain spaces to make sure that you can make that decision on when to humidify these days. But especially on the other end of the spectrum towards the mold side, relative humidity kind of gives you one idea, right? But it sometimes the real problem of it gets disconnected from the temperature. And so I've noticed getting dew point reports every now and then, which is really cool. But has there been any thought to actually display dew point in real time to really say, is there a problem? or is it just you have high humidity, but you have a low temperature, so maybe it's not a big issue?
Yeah, I think it's something we've experimented with a little bit, and so a lot of our devices have like a real-time API on the device, and particularly for like the smart home installations or building automation, things like that, where you can develop using like this data just available at an endpoint there. But yeah, I think kind of interested to see what we can do with more data, and focus on the 5 main air factors, or maybe the most like commonplace ones. But certainly there are ones like dew points that can be calculated from temperature and humidity, or relative humidity.
Right.
There's another one too, is absolute humidity.
Right.
And the actual water content of the air. And so they're all tied together. And I think one thing we've tried to focus on a lot too is like what's most relatable. So not necessarily like overwhelm you with all these sensors. It's like, okay, what are the most common ones, and the ones that you can draw other correlation. I think there's a question about like are there correlations between radon and some of these other air factors? Like, yeah, definitely. If you're practicing good air hygiene, then you're less likely to be susceptible to or exposed to any of these other airborne contaminants. So coming back to the laundry list of VOCs, well, if you look at TVOCs, and those are in a good range, like the specific ones, as long as the sensor is sensitive to them, don't it really matter. I mean, like, sure, every once in a while you might want to do like a lab sample or something like that, but on an ongoing basis, it's like if you see a spike, like, oh, room for investigation there, right? I mean, and like a massive spike or like a baseline that's just elevated, things accumulating and kind of raising those levels over time.
Thinking about putting myself in sort of the the builder architect who's sort of making this decision, if they're like, hey, we're going to put these in, obviously LEED's kind of talking a little about sort of that thermal or that breathing zone, that 3 to 6 height is where it's placement. So putting that into context, and then also just the fact that you have a device that is displaying, real-time information that you might want to be able to see. Given that, if people were building a new home or doing a major renovation, what would you suggest for placement? Obviously, it'd be nice if you could fund enough devices for almost every room, right? But maybe it's just 1 or 2. Like, where are the most important places to put these in homes? Have you seen builders be able to maybe build it in so that it's almost like a detector, right? It's sort of out of your way, kind of, you can see it, but it's, not kind of sticking out or has to take up table space. It's more of like a CO2. And I even think of like, obviously you want your smoke and your carbon monoxide hardwired along with battery backup. Those are LEED requirements, because if there was a power outage, but maybe you want this one hardwired too with battery backup. Is that something that's available? So I'm just kind of asking about like strategic placement of these devices a little bit. So
yeah, we've definitely had particularly like the larger homes or even ones done to spec by builders and stuff, where or multi-residential apartments and complexes and things like that. They will build it's like a little more commercial, like got a few more bells and whistles, but where Omni it does have those options for like building it in to the building. So as long as you spec it out and have the connection and stuff. I mean, it's got the Wi-Fi and everything else residential is, but there's some other connectivity power options there. But yeah, and to your point of like, where do you focus on monitoring? I've seen well, really it comes down to like, where do you spend the most time, or what are your goals in particular? You know, you might be more focused on, you know, because we're talking a lot about residential, like in maybe you monitor for a while in your bedroom and just see trends, and you correct some things, and you know, it doesn't mean that something won't crop up again, but you might be able to move that element, you know, from there to I don't know, a more common room like kitchen or living room or something, where you might spend a lot of your daytime. So yeah, it just really depends what your goals are. And there are some people are like, oh, I know I must have like tons of problems in the basement or something like that. You know, pop it down there, monitor things for a while, remediate or whatever else, and then move on kind of to the next room or something. But yeah, you know, if you can monitor multiple spaces at the same time, then it gets really interesting to say like, well, you know, levels rise in this room, like, so let's say from cooking, and then that travels to the bedroom, and then travels, you know, so you know, air indoors is so dynamic. You know, you almost kind of have to monitor every individual space, but yeah, you know, finding the right balance there for you.
We work with a lot of home inspectors or raters, assessors, going out and evaluating projects and trying to help people make informed decision by capturing information. A lot of that time they have to get that information sort of right there on the spot, which I know in the case of air quality monitoring is really, you know, a device that picks it up, and then laboratory testing, like the easiest one to think of is of course radon, but that's over time. I remember like one time, you know, like a home inspector, they leave that like little radon device in for a week, they come back and pick it up and they have some more information. What do you have, or suggestions do you have for the assessors and inspectors out there who might want to use some kind of strategy of having a few of these placed around, you know, and then moving them, like just based on how that could work, how much time they'd really need, or have you thought about that at all?
Oh yeah, we definitely worked with some like contractors and inspectors and other professionals that go in and offer those like remediation services and design and retrofits and, you know, whatever other services. But yeah, they'll you know, with the real-time monitoring and kind of cloud, you know, storage and access to data, it's really good to set a device there, leave it running for a little while, and then either collect it or had some just like end up reselling it to
Sure, that'd be ideal,
homeowner.
right?
They're like, just leave it here.
Right.
Like,
Yeah.
you know, this is just like, you know, blown our mind in terms
Right.
of the what we've learned while
Right.
it was here. You know, like, don't take it away.
Right.
So yeah, I think there's some good examples of that.
Great. Well, Dean, we are at our time, and I don't see any other questions at this point. So I really appreciate you. I appreciate Aware for helping educate us and talk about this important factor. And I think air quality monitoring, you know, 2022, that's going to be the year we got to do it. We got to get it in every project that we possibly can and be more informed. So on that, if people want to learn more, they want to reach out, they want to ask questions, where can they go to do that?
Yeah, you can go to our website, getaware, GETAWAIR.com. Yeah, and we've got a really helpful support team, answer questions, help with strategies, things like that. Yeah, we love consulting just as much as we do you know, getting people the tools that they need. So yeah, it was a real pleasure, and thanks for inviting me.
Yeah. All right. Well, thank you so much again, Dean Young of Aware. Thank you all for joining us. Stay safe, stay healthy out there, and we will see you all next week. Take care. Bye-bye.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.